Hello, this is Mr. Bradsby. Pleasure to be with you today. We're going to work some more on multiplication today. So I have a problem here of 3 times 10, okay? 3 times 10. We've been working a lot on our basic facts of up to 9. Maybe you've done 10, I'm not sure, with your teachers. But let's look at this and see if we can build a model. The first model I'm going to build is like a rectangle or an array, whichever way you want to talk about it. And we have 3, 1, space, 2, 3. Okay? So there's 3 down this way, 3 rows. Okay, now I got to have 10. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we have a rectangle here. And it is 3 units this way and 10 units that way. So if we're going to model this multiplication, look at how we get the answer. First, we need to count by tens. Have you practiced counting by tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100? I'll bet you have. Count with me, okay? We'll do count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Great. Let's count by tens. Right. Okay, so here we have 3 by 10. So if I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's right. So we have 10 here. And the same then on the next row, right? We have 10 there. And the next row, we have 10 there. Which makes sense because we have a 3 tens. 3 tens. And if you count by tens like we just practiced, we have 10, 20, 30. So the answer to 3 by 10 is 30. Not a very good 3. That's 30. Okay, well, what if I had 10 multiplied by 5. 10 multiplied by 5. Well, this is 3 tens, so if we just make it 5 tens. We got extended 4, 5. Okay, so we'll change this from 3 times 10 to 5, or 5 by 10. That's how the carpenters call it. They say a 5 by 10. And so the multiplication to them, they say is by 5 by 10. It's a 5 by 10. And that's what this rectangle is. It's 5 by 10. And so when we find the area, if these were all the same and made squares, that's as close as I can sketch it, we would have all the same rectangles, and the area of this, see, would be the 5 by 10s, which is all these squares. Well, we had 3 by 10 and got to 30, and so we have another 10 and another 10 because we got 5 tens. So again, this model shows us 5 times 10, or 5 by 10, and that would be 10, 20, 30, 40, 50. 5 tens is 50. Well, this probably is showing a pattern to you. Okay, so let's see if you see the pattern here. 3 times 10 is 30. 3 tens, 30. Okay? 5 times 10 is 50. 5 tens. Okay, and we showed them over here. We could count them all, but we know how to count by tens, so we can get that. Okay, I want you to put me on pause and answer these three problems. Okay, put me on pause and give me the answer to these. It should only take you a minute. Okay, 6 times 10, 10, 20, 30, 40, 50, 60. 9 tens is 90. 4 tens, 10, 20, 30, 40. And yes, I'm sure that's what you got. So what I'd like you to do, I'm going to write down a question, and I'd like you to put me on pause and finish that question, okay? Just 1 minute. I'll put you on. Okay, so here's the sentence I'd like you to answer. When you multiply by 10, how do you do it? When you multiply by 10. Example, 10 times 3 is 30. So complete the sentence. When you multiply by 10, put me on pause and answer the question. Well, I don't know exactly what you wrote down, but here are some things that I've seen before people write down. When you multiply by tens, you count by tens to that number or that many. For example, 3 times 10, I count 10, 20, 30. So the answer is 30. So that's one way of thinking of multiplying by tens. Another one, which is even a shorter rule that I've seen, is that when you count by 10, you add a 0 to the number. Okay, for example, 3 times 10 here, over here, 3 times 10. You take the 3 and add a 0, 30. So whichever type rule you want to follow, but that's what you end up with. You either count by tens to get there, or you just add a 0 to the answer. So that's what this shows too. 6 times 10, 60. 10, 20, 30, 40, 60. Or add a 0 to the 6. Add a 0 to the 9, you get 90. Add a 0 to the 4, you get 40. So there's some rules for multiplying by 10. All right, I have another problem here, but this one isn't multiplying by 10. It's multiplying by what we call a multiple of 10. 10, 20, 30, 40, 50, 60, again, are multiples of 10. So this is 20, which is a multiple of 10, isn't it? Okay, so let's look. How do I figure out the answer to 20 times 3? Well, I've built over here the grid, and if you count these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10. So there's 20. So we've got 10 and 10. So this represents 20. Okay, very good. The whole thing there is 20 of them. So I've got 3 20s. So I've got to go ahead and draw another one. 2 20s, 3 20s. And this is 10. So instead of drawing all those in, I'll just say this is 10, and this is 10, and this is 10, and this is 10. We could get that just by drawing all the lines in, couldn't we? Okay, so here we have 3 by 20. Well, how much is that? 3 times 20. Well, we've modeled it over here. Here's 20 long and 3 down here. So we have, I'll count them now, right, by tens. This is 10, 20, 30, 40, 50, 60. So the answer is we have 60 squares, 60 square units in this rectangle. And if we went ahead and marked them all out here, you know, you'd get 60. Okay, so there's a model of how to multiply 20 by 3. There's a mathematical way to do that. If we take 20 multiplied by 3, because 20 is 2 times 10, isn't it? We know that because we just talked about it. 2 times 10 is 20 multiplied by 3. Well, we have our commutative and associative properties that say you can multiply in, as long as it's all multiplication, you can multiply in any order. So I could multiply 2 times 3 times 10, which is 6 times 10, and we just talked about 6 times 10 is 60. So that's a mathematical way of doing it without looking at that. In other words, 3 times 2 is 6. 3 times 10, I'm sorry, 3 times 6, 3 times 2 is 6. And so, again, multiply that by 10, we get the 60, because there's in the tens place. Okay, 6 times 10 is 60. So there's a way to model multiplication by a multiple of 10. All right, well, let's look at one more problem here. 40 multiplied by 4. 40 multiplied by 4. So again, we'll need 4. There's 1, 2, 3, 4. Now, instead of putting all the lines in, you know what happens when we get to 10. So we'll say these are 10s. That's a 10, that's a 10, that's a 10, that's a 10. Okay, these are 10s. So there's 1, 2, 3, 4 10s. I got to have 40. Okay. Okay, so we have 40 for 10s. I can trim this up if I want, so it, there, that looks a little better. But 1, 2, 3, 4 here by 40, 4 10s by 40. Okay, so again, we can count these 10, 20, 30, 40, because that's what there is. There's 40 across. Then another one, 50, 60, 70, 80, 90. Oop, there's 100. So that makes 100. Okay? So 4 times 40 is more than 100 of them. Let's see how many more. 4, there's 10, 20, 30, 40, 50, 60 more. So the answer is 160. Okay, then I could show you the mathematical way. So let's look at that. 40 multiplied by 4. We know that 40 is 4 times 10. Another way to write it, times 4. And with commutative, we can switch these positions here. Commutative property says you can change them without changing the value. So it could be 4 times 4 times 10. So look what we did. We just took 10 times 4, which is 40, and made it 4 times 10, which is 40. Same thing, isn't it? So that's all we did. So then we get here, 4 times 4 is 16 times 10, which is, following our rule, 160. Just what we got here when we built the model, 160. So there's a mathematical way to do it, and there's a model for it. Let's look at one just mathematically. You see how to do that. 30 by 6. I'm not going to build the model this time. I'm going to do it mathematically. 30 multiplied by 6, okay? 30 is 3 times 10. We know that. We talked about that. Multiplied that by 6. So this is the 30 times 6. Again, the commutative property says we can change the order without changing the value. So 3 times 6 times 10, okay? That's 18 times 10. And following our rule, it's 10 times as much. You add the 0. The answer is 180. So there's a way to do it mathematically. 30 times 6 is 3 times 6 times 10, or 18 times 10, or 180. Okay, well, there's a mathematical model for you. It's been a great day today. I think the teachers may answer any questions you have and maybe have a little practice for you. It was a great day today. I enjoyed it. You enjoy your mathematics.